Expanding brackets, double brackets with Adam Maths Tutor. Here are the beginner questions. These are some of the easiest questions that you're likely to see on this topic. When expanding pairs of brackets, multiply each term in the left bracket by each term in the right bracket. I've found from my experience, the best way to keep track of the terms that you need to multiply and keep errors with signs to a minimum is to use the grid method. Similar to when you multiply a 2-digit number by a 2-digit number using the grid method, we would split the 2-digit number into the number of tens and units it has. So in terms of the pairs of brackets, we'll split the b plus 5 into b and plus 5. Then looking at the other bracket, this can be written along the side and be split into b plus 4. So this ensures that everything in the left bracket is multiplied by everything in the right bracket. And we'll start off by doing b times b, which is b squared. Next we can do b times 5, and I would encourage you to write down the correct signs as you go along as well. So this would give us plus 5b. Next we have b times positive 4, which would be plus 4b. And lastly we have positive 5 times positive 4, which is plus or positive 20. This is the expanding part of the question complete. Now we need to simplify by collecting like terms. B squared does not share any other like terms, so this would remain as b squared. However, the 4b shares a like term with 5b, so positive 4b plus, because we're collecting like terms, positive 5b would give us positive 9b. And similar to b squared, 20 does not have any other like terms, so we'd leave this as plus 20. So the final answer is b squared plus 9b plus 20. Next, we need to be a bit more careful because we have the inclusion of some negatives. Y minus 8 across the top, y plus 3 against the side. Multiplying each of these terms, y times y is y squared. Y times negative 8 is negative 8y. Y times positive 3 is positive 3y. And positive 3 times negative 8 is negative 24. Y squared. Now collecting like terms, we have positive 3 and we're adding negative 8, lots of y. So forget about the y for now and just focus on using the number line to work out what these two numbers would be added together. So 3 and then adding a negative number would have the impact of subtracting. So 3 take away 8 is negative 5. So therefore collecting like terms, we would have negative 5 lots of y. Minus 24. On to the intermediate questions with a slight increase in difficulty. Whenever you have a bracket which is being squared, this means the bracket is being multiplied by itself. So that means that x plus 3 would be multiplied by x plus 3 and therefore ending up with double brackets. Drawing a grid and multiplying would give us x squared, positive 3x, and positive 9. Collecting like terms will leave us with x squared plus 6x plus 9. Secondly, we have x plus 7 in our grid and x minus 7. Multiplying will give us x squared, positive 7x, negative 7x, and negative 49. Collecting like terms, we have x squared, adding 7x and negative 7x together will cancel, leave us with 0x, so we don't need to write this down. And then lastly, we would have negative 49. So we end up with x squared minus 49. This is a special case where the term here inside the bracket is the same as the term here, and the term here is also the same as the one here, but these are separated by one being a positive and one being a negative. So the middle bit ends up cancelling out when you collect like terms, and you're just left with the beginning part and the end part. And this has a name. It's called difference of two squares because you end up with two square numbers and the difference, a subtraction between them. On to the advanced questions. These are some of the trickiest questions that you're likely to see on this topic. In the first question, we have a multiple of x which is larger than 1. So across the top we'll have 3x and negative 7, and across the side we'll put x plus 4. This means that when we do x times 3x, we're actually going to end up with 3x squared this time. X times negative 7 is negative 7x. 3x times 4 is positive 12x. And then negative 7 times 4 is negative 28. Collecting like terms will leave us with 3x squared. Adding these together would be the same as 12 take away 7, which is positive 5x. And then we still have negative 28 at the end. So 3x squared plus 5x minus 28. For the last question, the area of these shapes are the same. Find x. You can see that we've been given two rectangles. To work out the area of a rectangle, we need to do the length multiplied by the width. You can see that the length is given to us as an algebraic expression with two terms, and the width is also given to us in the same format. Because we're multiplying two terms in an algebraic expression by another two terms, the use of brackets would be good. That means we need to multiply 2x plus 4 by x minus 3. Multiplying our terms together, we get 2x squared plus 4x minus 6x minus 12. And collecting like terms, 2x squared minus 2x minus 12. For the second rectangle, we're multiplying the length, which is two terms, by the width, which is one term. This won't be pairs of brackets, it will just be a single bracket with 2x outside and x minus 4 inside. 2x times x is 2x squared, and 2x times negative 4 is negative 8x. We were told that the area of these shapes are the same. That means that the expression that we got for the first rectangle, 2x squared minus 2x minus 12, would be equal to the expression that we got for the second rectangle, which is 2x squared minus 8x. Next, we can begin to solve this by making it equal to 0, and I could start that by taking away 2x squared from both sides. That would leave me with negative 2x minus 12 on the left hand side is equal to negative 8x on the right hand side. Then I can add 8x to both sides, leaving me with 6x minus 12 on the left hand side and 0 on the right hand side. Adding 12 to both sides, 6x is equal to 12. Divide by 6, x is equal to 2. Before you go, take a look at the solution which I've provided for a question. It appears as though I've made some mistakes. Pause the video, let's see if you can spot what they are, and either tell me or write some corrections in the comments below.
Thanks for watching. If you found that video useful, don't forget to hit the like button and leave a comment. If you're struggling with maths or finding topics difficult, you can subscribe and turn on notifications to receive regular updates about new video tutorials. Don't forget to visit my website adamonlinetutoring.com for a full searchable list of all topics with exams, questions and solutions. You can also visit me on social media using the handle @AdamMathsTutor on Instagram, TikTok, Facebook and Twitter. All links in the description below.